I'm Ines Fong, 中文名係馮佑常。I'm now a professor of atmospheric science at the University of California, Berkeley. At MIT, I got my undergraduate degree in mathematics, and then I got my graduate degree. It's not a PhD, it's a Doctor of Science, but it's equivalent to a PhD in meteorology. But for me, it's not studying the weather, but studying how the atmosphere works. So I went from studying mathematics, trying to figure out traffic flow, when there's a red light, there's a shock wave coming, and writing equations for that, and then learning to write equations for other phenomenon, and then trying to look at hurricanes. For me, studying the atmosphere was interesting because, I grew up in Hong Kong. Typhoons. Okay, typhoons as a child was bad because I couldn't go to the beach, but typhoon was great because I didn't have to go to school. So science seems like the logical thing to do, right? Mathematics to me is elegant. There's an equal sign, okay? Everything is calm, there's a balance. The left-hand side equals the right-hand side, so I really liked it. All the equations I learned, the mathematics I learned, I can write equations for the clouds. I can write mathematics to explain the cloud structure in a typhoon and a hurricane. And that was very useful because when the hurricane actually came to Boston, when I was a student, I know how many minutes I have to sit in the coffee shop, and then how many minutes I have when the rains lessen, and then I can run. It was very useful, but I couldn't predict the weather. I couldn't do anything. But I was studying mainly the mathematics of how the system works. And then from the atmosphere, for me to study other aspects, the carbon, the vegetation. Basically, I'm now studying the whole Earth. Okay, so basically, I also like puzzles. So for me, it is now like I'm playing puzzles. Nature is just so much smarter than we all together could be. So every time I think I've solved a problem, nature gives me a new problem, and that I thought I had solved it already, but nature says, oh no, wait, okay, here's a new problem, you're not done yet. So I'm really having a good time. You have to look at me, right? I have white hair. When I entered MIT, it was the era where unmarried women under the age of 21 had lived in supervised conditions. So a lot of whether MIT or any school could accept more women depending on how much dormitory space there was. So MIT, the year I was there was, in my class, there were 75 women among 1,000 men, and that was the largest class that they had accepted. Now it's over 50%, but at the time it was 75 women. But in the end, it doesn't really matter, right? You go to class and you sit there, you don't talk to anybody, you just sit there and take notes, okay? You come back, there's a whole dormitory of friends. And then when I went to graduate school, I think you might know, I'm the second woman PhD from my department. But it didn't matter because we all work, right? You all do your work, you all do your homework together. We all went to lunch every day at 11:30. The people my office mates, the people that I associated with, we all talked the same thing. Nobody said anything that I did. We had several international students. The different places I've been and the different people I've interacted with, it's been really enriching. Okay, different people have different perspectives, and you see how you can learn from those different perspectives. And so it's so much easier. It's tougher for me to switch between Cantonese and English where I am, because very few people speak Cantonese where I am. But for the science, now I'm studying the ocean, I'm studying the land, I'm studying I'm studying how plants work. Everything is tied together. We live on one planet. And so this is really exciting to me. Well, science is what advances our civilization. Okay, so this is, I work on climate change, but I didn't work on climate change because it is a problem. I just wanted to know how the climate works. So one thing leads to another. I don't, it's not like I solve problems. I don't starting out solving problems. That's, okay, I just want to understand something. Okay, I want to understand why the rain falls over here, over the Amazon, and not over the Sahara Desert. Okay, I want to know why there are typhoons over here and not over there, right? I want to know, it's always why. When I was a child, they called me difficult because I was asking questions all the time. Okay, so there is no way you can predict where the new science questions are. If I'm really smart, I would have solved some problem I started out with. I'm not that, but if I were really smart, I would have solved the problem. Then what? So as a young person, you have to have an open mind. Very important to build the foundation. So take biology, take chemistry, take physics, take math, take literature, take philosophy, take whatever you can. Build your base. Because that's the foundation upon which you can build bigger things. Okay, so I started not knowing, I'm still struggling to learn biology. I was more in the physics and mathematics side and not in the biology side. But new technologies come along and you have to be prepared, right? New things come along, new ideas come along, and if you don't have the base, it is difficult to build on that. It is, we don't know what the future holds. We don't know the direction. We don't know, the iPhone came just slightly over a decade ago, right? There's no way I could have predicted that would happen. There was no way I could have predicted the drone or the Zoom or, any of the things that we're using. And we adapt to it, but that means that whoever is working is building always the fundamental. We always, where I am, we always say, go to first principles. Build up your first principles, those, and then you can address new questions.
Ladies and gentlemen, welcome to the seminar of Wonder Women in Science, Inspiring and Empowering the Next Generation, organized by the Council of the Hong Kong Laureate Forum, which is also named HKLF. My name is Laura Kosensen, your MC for the day. On behalf of HKLF, a warm welcome to all of you who are participating right here physically with us today, and to those of you who are joining us online. Let's all wave to the camera. They could see us, that's right. Joining us from around the world through the live webinar. Thank you for joining us today. Just a minute ago, we had a very interesting sharing from Professor Ines Fong, Professor of Atmospheric Science of the Department of Earth and Planetary Science and Department of Environmental Science from UC Berkeley. As you could probably tell, she is not only amazing, but humorous and curious and inspirational. Given the time zone difference, we cannot have her here with us today in person, but it is our immense honor to have interviewed her in the past week. And if you have not had a very good taste, if you had a very good taste of her video just now, you would be pleased to know that the full version will be made available on our website and social media later. So do stay tuned. And to start off today's event, we would like to invite on stage Dr. Rita Fan, member of the Board of the Council of the Hong Kong Laureate Forum, to come forward for words of welcome. Dr. Fan, please.
Chairman team, learned professors, friends, young ladies and young gentlemen. A very good afternoon to you all. You see, I got a draft speech, but I'm not going to use it because after seeing Professor Fong's interview, I'm very much moved. You see, I study science in the University of Hong Kong. I even managed to get a chemistry prize. But I know in my heart, I am not a scientist. I haven't got the persistence, the patience, the need to notice every little detail, to record every little happening, so that I could form a hypothesis, and then I test out the hypothesis. That's too tiring for me. That's why I'm standing up here. But that's not a problem. The main thing for us in life is to pursue our interests, to enjoy what we are doing. And I think Professor Fong shows us she is really enjoying every moment of it, because she sees some phenomenon happening in the weather, and she said, why? I must find out why. Now, that is the first, in my view, the first step of science, the curiosity to try to answer a question in one's own mind. And then the determination and the persistence to try to carry on and find out more. Now, women are very well known for our persistence, particularly with our husband. And we are also very well known for our ability to notice details. That seems like a very good foundation for scientific research. Actually, I don't want to differentiate between the male scientists and the female scientists, because everybody really works together. But there are relatively fewer female being well-known, renowned scientists. Somehow, they don't seem to get the publicity. But a few of them did pass that hurdle and become very well known. Now, of course, anyone here, apart from Professor Fong, can you tell me a woman scientist that come to your mind? Come on, you are better than this. Nancy Yip. Nancy Yip, yes, very good. Hong Kong product, ha ha ha. Any else? Curie, of course, Curie. Curie actually not only well known for her scientific research, she is also the only one so far who have got 2 Nobel Prizes, one in physics and one in chemistry. Now that is a feat which no other scientist has yet achieved. I'm sure in future there will be. But there is also example of scientists working very hard and yet doesn't get recognition for it. Have you ever heard of a scientist called Rosalind Franklin? Yes, of course, you know she made this significant contribution in the discovery of the double helix structure of DNA, but because she died of a very young age, in her 30s, she never got recognized. In fact, other people who follow on her work got the Nobel Prize. But that is not as important as being able to do something that you enjoy doing, that you really like doing. And I hope the main thing for today's activity is not only looking at the boards, but further on the discussion with renowned scientists among us, sharing their experience, knowing what it means to be a scientist. Now, I've just been telling you something nice about being a scientist. Let me tell you something which is not so nice. You find yourself trying to work out things, and yet you are in the total darkness. You don't seem to make relationship between one finding and another finding. And then when you started to find some relationship, suddenly there's a third finding. You are not expecting it. So back to square one. Isn't that very frustrating? And yet, if you love science, you find that very interesting. You find that very challenging. So I hope today will help you to understand more about scientific research. The happiness, the bitterness, the sweetness, and the sadness. I also hope that after today's function, you will feel that perhaps your future lies in the laboratory or lies up there in a drone trying to find out what the weather is doing. I hope this will inspire you, and also I hope you will enjoy it. Thank you very much for coming.
Thank you very much, Dr. Fan. Thank you. Please be seated. Well, we've all got the first principle of scientific pursuit, which is curiosity and loving what you do. Thank you, Dr. Fan, indeed. Very encouraging. Well, in a minute, we will be inviting 3 renowned female scientists to share with us their research journey as well as their personal views. Whilst Professor Chang and Professor Ng are able to join us in person, we do have Professor Foyer who will be joining us online. And with this opportunity, we would also like to express our gratitude for all the guest hosts today who are joining us here. And you will be hosting the Roundtable Dialogue session following our seminar later. So a big thank you to all of you. And throughout the seminar, we do welcome questions, both in person and with our online audiences. So after each of our scientists' presentation, we will be answering a couple of questions during the panel discussion and the Q&A session. For friends joining us virtually, you could utilize the Q&A icon on the virtual platform to ask us any questions. And without further ado, we would like to invite our first Professor Sriu Ng, Director of Microbiota Eye Center and Professor of Department of Medicine and Therapeutics from the Chinese University of Hong Kong to present for us. Professor Ng, please.
Thank you very much. I'm very much inspired by Dr. Fan's speech, and I'm thrilled to be here, and thank you for this wonderful opportunity to share my little sort of humble journey. So my story began, I was born in a little island Penang, Malaysia, where I grew up, and at a young age, I've always been fascinated by the human body. So my parents gave me a lifetime of their savings for my education and went to one of the oldest schools in London and did a PhD in Imperial College. 12 years ago, an opportunity arises, and I came to Hong Kong to join as a junior faculty at the Chinese Museum of Hong Kong, and my 2 kids are born in Hong Kong. And throughout this journey, people always ask me, what do you think is the secret shortcut to success? And my answer is 0. There isn't any secret shortcut. I see a lot of disappointment sort of faces here. But along the 20 years, I've sort of witnessed, and I think research has backed this up. In any of these different contexts, there's one characteristic that emerges that's a significant predictor of success. It's not social intelligence, not good looks, not physical health, nor IQ. Can anyone tell me what you think it is? There's research backing up greed. So Dr. Fan rightly pointed out, in my personal dictionary, greed is grinding to the end. And unfortunately, this is part of, I think, perseverance in life, in whatever you do. And in scientific discovery, this applies too. Many of us see the tip of the iceberg. There's this iceberg illusion that success is an iceberg. But just look under this iceberg. What did you see on the left? Persistence, failure, sacrifice, and disappointment. And on the right, you need to have dedication, hard work, good habits, turning bad habits to good habits. And I want to give 2 examples. And I think for females, sometimes the magnitude can be larger in some sense. And I just want to give you 2 examples. Wendy was my PhD student. She's now the mother of this little girl. And most evenings, she's in the lab writing grants to meet up the deadlines. And of course, Lynn has 2 sons in Shenzhen, and she lives in Hong Kong. Because of the pandemic, she has not seen them for a year. So I think essentially, this was where I came from. And being able to understand that, and I think not to take it for granted is important. My little girl, Olivia, has so much curiosity when she sees Oscar. She's, by the way, I saw a lot of her seats there. She's in TGJS at the moment, and son in CVS. And I think this is what you need, passion and curiosity, just as you see what little lives are at the moment with that. And I came to Hong Kong in 2010 as a one-man band, essentially wanting to do a research for a condition that doesn't exist. It was called inflammatory bowel disease. It was called a Western disease at that time, but now many young people have it in Hong Kong. What's ironic is all my mentors have been males, and they are giants in the field. Professor Joseph Song was the president of CUHK, now the dean at NTU in Singapore. Francis Chan is the dean of medicine now. Henry Chan is leading a key private hospital in Hong Kong. And Justin was the ex-COO of our CUHK Medical Center. And I think it's very important, with all these mentors, I take something away from them. But it's important to be different because you build your identity along the way and you learn, I think, from the best, essentially. And what I noticed is that females have a lot of mentors, but one observation is that they're a little bit under-sponsored. And when I said what sponsorship means, it is about charting the path. It's not about just showing them the door, it's opening the door, small and large for you. So for example, giving opportunities to male and females together for meetings and nominations are very important. So right now we have a big population at 63% in the sort of science park, And recently we just empowered budding scientists internships. So these are people from CIS, German Swiss, as well as different local schools who really look at them wearing their gowns in the animal facility, trying to understand what science is all about. But for me, I wear 3 different hats. I'm a gastroenterologist, so most of the time I do endoscopies, I see patients. But sometimes, half the time, in the laboratory doing science as well. But recently, being inspired, we founded also a new biotech company as well to translate our findings to the society. So we were very fortunate because we built the first Center in microbiome at the Hong Kong Science Park with the blessing of the ex-chief executive in order to turn Hong Kong into a biotech in the next few decades. And this is where we are based. I co-direct this with Professor Francis Chan. I want to share with you what the mission is. It's something maybe new. We want to transform health through diagnostic of understanding of a gut microbiome. So the facts is that this is now the new buzzword in everyone's dictionary. Now we talk about the bacteria inside you, how microbes make man, even in the economists at the moment. So why do we say that? Inside each of you, there are trillions of microbes that are just our second brain in helping us govern a lot of things. And why I say that is because for those students who have done science, you may know that each one of you have 20,000 human genes. But do you know you have 20 million bacterial genes? Essentially, if you count the DNA of you, you're only 1% human. The 99% of your genome are your bacteria. This figure may not be so important to you, but look at this figure. Right now, we know when you have imbalance of these gut microbes, essentially, you have many different disorders from cancer to eczema to autism due to the imbalance, and more recently to COVID as well. So my innovation and what our team do is just by taking 1 spoon of stool from you, we can now know what kind of disease and predict your health and diseases as well. So with that stool, we can generate tons of data in this DVD. So the next time you're in the toilet taking a data dump and flush it away, just think of that for a moment, because some people may think this is science fiction, but I'm sure at the end this is happening now, today. So we have now had the technology of detecting colon cancer early from a stool sample before it becomes incurable. And this has sensitivity of 94%. We can also use a stool test to detect the risk of autism. And with this, perhaps we can change lives that when they are very young, 1 or 2 years old, we can know and prevent the misbehaving or different types of phenotype from occurring. But many people think that what happens is with the COVID, it has caused a lot of disruption with science. But with that, I think there are also opportunities because we ask the question, why do some people get so sick with COVID and others don't? We identify certain gut microbes that we know may be beneficial in their gut, and using a machine learning, develop a formula, SIM01, that can boost immunity in some of these people. And now we've seen that some of the early results show by increasing the good bacteria in a gut, you can actually increase immunity against COVID-19 vaccine as well. So people think that what we do is funny because we take feces and turn it into drugs. Some people call it a crapsule or poop pill, but this is what we want to do, tailored medicine to people, which is what's happening in the next era. So many ask me why I choose this path as a scientist. I think you meet different people from around the world, and it's really fascinating. And at the moment, you can do cutting-edge research that turn what you do from the bench to the bedside as well. And at the same time, you can do something creative and innovative in a very sort of flexible environment. And I think this is what science is about. Serendipity happens. But for a lot of young people, I think the formula of successful scientists in my mind is the passion and the energy, the adaptability, continuous to develop yourself. I would say it's like a marriage. It's a long-term investment. Once you're in, hopefully you will continue and persevere. And it's important to develop a little niche for yourself and build yourself and always create opportunities for yourself. I think that's really important as well. So as you go through this journey, there are lots of humps and bumps and everything. And I want to share this very interesting paper in Nature Communication. It says researchers find that early career failure promotes future professional success. Isn't that fascinating? In fact, this is from one of the Nobel Prize winners saying our results do not imply we should strategically put roadblocks in front of junior scientists. The precondition of becoming stronger is not to be killed in the first place. But for those who persevere, early failure is not a negative side, but rather the opposite, in line with Yamanaka's that after winning the Nobel Prize, I can see any failure as a chance. In fact, that's what the philosophers from Germany say. That which does not kill us makes us stronger. I think there's quite a lot of truth in there. So many see success as the left, but actually this is what it really looks like for most people. So from this bumpy journey, is there something you can lead further? And I think for myself, the journey ended with entrepreneurship. In other words, can we turn what we do? I don't want it to just sit in a library or basically in a journal to the sort of mankind. So about 3 years ago, we founded a scientific biotech called Genibiome Company and hope to be able to turn some of these scientific discoveries with patents helped by Professor Z from ORKTS to turn them into discoveries that can actually perhaps change, impact the lives of people out there. So right now, we're very fortunate to have the Geneva Inventions Innovations Award for some of these discoveries from Hong Kong. And last but not least, during this journey of entrepreneurship, there are two things that I've learned. One is you need to 摸住石頭過河. A lot of times you have no idea what you're doing, but it's okay because it's one step at a time. But when you do science, it's important if you can leave no stone unturned. So what's the next 10 years or 5 years for me? Many people ask. At the moment, we see a big problem. What we're doing is that many diseases are increasing. Diabetes, autoimmune, multiple sclerosis. And this is because we are wiping our good bacteria with the bad things we do. Antibiotics, lifestyle, healthy, so less healthy eating. So many people have been hunting for the good bacteria, the thing looking back into ancestral, who are very healthy, who don't have modern lifestyle. But can we take the microbiome and transfer it to us? Some people may think this is a little bit unethical at the moment. So we have a new concept of what the next 5 years is shown. If people can do cord blood, right, to save it for genetic diseases in the future, people cryopreserve their sort of eggs. How about a microbiome vault? Essentially meaning that saving your stool when you're young and healthy, and then when you're old and maybe have dementia or frailty, be able to transfer that. I know this sounds like science fiction, but this is really happening already in the West. This is the global seed vault. They store all the seeds of the genomics for the last 10 years so that we don't run out of starvation. So one day we will still be able to use it 20 years down the line. So this is what we are doing, an Asian microbiota vault for humanity in the Greater Bay. We call this the Chinese microbiome Noah's Ark, essentially, whereby you store what you need for the future that you may be able to use. So collect, preserve, and enable. So last but not least, this is not an illusion. I think it's important to believe, but you need to build an ecosystem along the way. And this ecosystem is important. They can be your mentors. They can be health, wellness, reverse mentors. Some of my students are my mentor in some ways. They teach me things that I never knew about, IT stuff and business stuff, or spiritual and even brain, as well as vent buddies. But for feminine leadership, I think the 3 C's I always like is the creativity, competency, and compassion. I think you can be accountable and competent. You can lead in different ways as feminine, actually. You can be vulnerable and yet be accountable, and yet as well as competent. I think all these equations really match up for that. Last but not least, I think to all my female male peers, I think it's really important we work together. It's important to create and communicate vision, develop a strategic plan, and always try to have different mentors as well. I think this is what can bring us a really great ecosystem. So if cauliflower can become a pizza, I think we can make a change. And last but not least, I believe every single one of you here have some magic inside you. It's just a matter of how you discover that. Thank you very much for having me.
Thank you so much, Professor. Thank you. Please remain. I'm most mesmerized by your presentation. I mean, from different angles, from a female angle, from a science angle, and even from an entrepreneurial angle. So let's see what questions we have from the different means of joining us. Well, we would now like to look at the questions from the audience. But what was the reason that made you specialize in gastroenterology?
Thank you very much. So basically, gastroenterology means I deal with anything from the mouth all the way to the anus, the whole human gut. And I've always been fascinated basically with my hands. I wanted to be a surgeon initially, but then gastroenterology offers you two things. You can think with your brain to treat the patient and the disease, but you also get to use your hands to do endoscopies for patients. So essentially, you can combine the craft of it as well as the art of it. So I think medicine is like science is like basically art and sort of science combined together. So that's the reason. And the second reason is gastroenterology. People think when you do with the heart, you have one organ. Do you know that with gastroenterology, you have like 5 or 6 organs? You basically have your food pipe, you have your stomach, you have a pancreas, you have the liver. So people can have a lot of specialty within that as well. And of course, not that I'm biased, a lot of the gastroenterologists are very nice and friendly.
Well, so aside from that, we do have quite a couple of questions as well. So the next one is, how is it to lead 15 countries and 30 centers into studying inflammatory bowel disease? It's more another question on my mind. How do you marry science and entrepreneurship?
So I think this is such a great question. The first thing when I arrived in Hong Kong was because inflammatory bowel disease was so rare and nobody really know much about it. And if I go on my own, it's going to take me a long time to work on a rare disease. So I thought, one thing is you work together with other Asian countries that also have this rare disease. So we form a network of 15 countries. So I think the moral of the story is don't do it alone. Go in united. So within that 15 countries and 30 centers, I made a few things. I made a lot of friends and become internationally more well-known within the people. I provide an opportunity for those centers to also study a rare disease within their center, which is in Asia. And now 10 years later, I made like hundreds of friends from these people because we went through this journey together and we mapped inflammatory bowel disease in the whole global map, that this is not just a Western disease, it also happens in Asia.
Right, so is there any breakthrough that you felt, I couldn't have done it myself, it has to be the team?
Absolutely, because I think a lot of scientific discovery, you might have an idea, but in order to execute it, you really need sort of the team. So we are able to work and find, look, certain food causes inflammatory bowel disease increases, certain hygiene status causes it, but you need to be in different areas and different geography in Asia to identify that.
Right, that's wonderful. Well, could I borrow your applause to Professor Yin for a wonderful presentation? We look forward to seeing you back again at the panel. Well, there is a lot of food for thought, and there is also some new vocabularies that I learned, like data dump, right, and the Noah's Ark of microbiota. Those are terms that I'm going to remind myself from my science learning days. Well, up next, we're very excited to have Professor Christine Foyer, who will be joining us from the University of Birmingham in the UK, joining us live. She is the Professor of Plant Sciences at the School of Biosciences, and we are having her to join us today. Let's all put our hands together to welcome Professor Foyer. Hi, Professor Foyer. Nice meeting you. We have a group of very anticipative audience in the room, and if I may now hand the time over to you, please.
Thank you so much. It's a great pleasure for me to be here today and to talk to you and share some of my experiences with you. This blurred slide just says something about me and what I do now. As you said, I'm Professor of Plant Sciences at the University of Birmingham. And so I do the things that other people do in an academic life. I do research, I do teaching, I do administration. But on top of that, being part of the academic world allows you to do many other things which are very interesting and exciting. So at the moment, I am president of a scientific society called the Association of Applied Biologists, which again allows you to develop a network of interests beyond what you would normally have within a university or a research organization. I belong to the French Academy of Sciences. I sit on many grant panels, so I spend a lot of time assessing grants and being part of the system that is able to distribute research funds. I sit particularly on the European Research Council Consolidator grant panels, which enables me to be involved in seeing young researchers come through and to provide resources for young researchers. If you look down the list, I'm also on prize panels. So as well as being able to award funds, you can acknowledge the achievements of people through the awarding of prizes. And this work gives great satisfaction in addition to the scientific career. As you see below, I also work in relation to industry and the food industry in particular, looking at the quality and the future of food, which is particularly important in this world of uncertainty. Food security and the quality of food is essential to our future, but it's by no means certain that we will have enough food and nutrient-rich food in the future. So I do these different things. I'm also an editor-in-chief of a journal, Food and Energy Security, and I sit on other editorial boards. All of these things come with an academic life. So in addition to research, there is a possibility to do a wide variety of things which enrich life, enrich careers, and enable you to be part of the development of science and the development of careers in the future. And the very last thing is my H-index. Now, I know in these days where we are asked not to look so much at metrics such as H-index, but to look more in terms of the impact. This kind of metric isn't as well respected as it was. But as a scientist, it's often very hard to get recognition, to have recognition, or to understand recognition within the wider world. And it's natural to have almost imposter syndrome, to think, well, yes, I've done something, but maybe it's not so good. But when you look at a metric like the H-index, it is absolutely irrefutable. Here you have data on how much impact your science has in terms of it being cited. And in a world that is often very competitive and difficult, it is really quite reassuring to know via some kind of independent metric that you actually are achieving impact. You always hope that you do. So I do believe that sometimes from a personal, not from a view, can be very important. So I want to say you something about my career. As our first speaker, I've been in science a long time, but I was never the kind of child that was fascinated by science. You know, you will hear scientists say that since they were children, they always loved this and they always loved that. I was never that kind of person. But I always loved problems. I always loved learning. But I was a typical teenager. You can see some photos of me at the left is I entered university, and the one on the right is when I started to become fascinated by science. But it was that I was interested in problems, and I was good at other things. I was really good at history and English and economics, but I decided that biology was challenging. So I decided not to do what I was really good at, which was the English and history, but really to go into biology because I thought it was a challenge. So I did my first degree in biology, and I fell in love with everything. And like many students at that age, even now in my university, students, when they come into university, prefer animal science to plant science. And I was no different. I really ended up, when I had my first degree, being fascinated by animals. And in particularly, I loved embryology, the development of the embryo. And I was really interested in working in the field of test tube babies, which was just starting to emerge at that time. And I started to look for jobs in that area. But at that time, and possibly still now, the work involved killing a lot of animals. And I decided really at that point that I didn't want to spend a career involving animals because it just wasn't the path that I wanted to go. And I was very lucky that I had one of my tutors in college was a plant scientist. His name was Barry Halliwell. And he said to me, would I like to do a PhD in plants? And he gave me that opportunity, and I really never looked back. My PhD wasn't easy, and maybe for some of you that's absolutely the case. I spent the first year of my PhD trying to isolate an enzyme called ascorbate oxidase from banana fruit. And if anybody has worked with the pulpy fruit of banana, they'll know what a difficult material it is. I spent a whole year using a myriad of different extraction procedures, and I could never isolate the enzyme in an active form. And my PhD supervisor, Barry Halliwell, said at that point, we have to stop. You can't keep on doing this because it isn't going to work. You know, the technology isn't there, at least at that point. And so I changed topic completely, and I was thrown into the world of reactive oxygen species. And I actually never looked back. When I realized that the air that we breathe is toxic, and we only survive in oxygen because of the antioxidants which have evolved to cope with the reactive oxygen species, which were produced as a side reaction of life in oxygen, it was immense. It was like a revelation. And I've been fascinated by reactive oxygen species ever since. And it is a field that was tiny in those days, but it has exploded, and people are still finding more and more roles for reactive oxygen species today. It's amazing that it continued from a very small beginning to be almost part of every aspect now of plant biology, as indeed perhaps animal biology. So I ended up doing my PhD in 2 years. And at that point, that was because everything that we did worked. Despite me having a road accident that time, I was actually knocked down in Oxford Street by a post office van, and I ended up in hospital for several weeks. And it was just a time which was full of promise, and the experiments that I did worked. So I was able to do a PhD in 2 years with success. And I look back very fondly at that time you know, how much I learned and how much we managed to achieve from very humble beginnings. And really, I was very lucky because I was in a small lab. I was the first PhD student of my supervisor. So literally in the first days, we were setting up the lab, and my supervisor supervised me, and the work really just flourished and the lab grew from there. But it was very humble beginnings we started from. So from there, I've had a very varied career. And I'll maybe explain to you a little bit why. I've worked in so many different places. So you'll see my professional experience there. I started off not moving far from where I'd done my PhD, and I did a postdoc in a different department of King's College at the University of London. But again, it was a time of learning. From your PhD, I think it's quite a big step to moving to being a postdoc, learning to be independent, learning to work without direction. And those 2 years were able to give me that kind of grounding. So I then moved into a different university. I went to the University of Sheffield. And you can see that I spent nearly 10 years there as a postdoc. And I spent that 10 years there because I really enjoyed being a postdoc. It is actually possibly the best time of your life because you don't really have any worries apart from your research. I just love my research. I was able not to do the kind of experiments that I wanted to do. I didn't worry about where the funding was coming from. I didn't worry about administration. I was shielded from that by Professor David Walker, who was head of the institute where I worked. I was working in the field of photosynthesis, but still looking at different aspects, some of which involved reactive oxygen species, others which involved sugars and the end products of photosynthesis. For me, it was a really interesting time. I perhaps should have moved from there sooner, but I wasn't thinking of a career. You know, at that time, you have a family, you have children, and I was kind of not so thinking about a research career, but more just enjoying my science and enjoying my life. But at a point thereafter, you can't stay as a postdoc forever, at least in very exceptional circumstances. And I was very, very lucky to be offered a post in France as what they call a director de recherche, which is basically a lab leader. During my time at Sheffield, I'd obviously grown. I started off as a basic researcher, but then I started to take PhD students as well and be involved much more in the training of young researchers. So I was able to move to France, where I was given this opportunity to run my own lab. And that was absolutely wonderful. And I very much enjoyed being in a different situation. And perhaps, I mean, it was really difficult. I went to France where everybody spoke French in the lab, and I spoke very little French. So it was a very steep learning curve, but it was a wonderful learning curve. I perhaps would have stayed there much longer, but family considerations meant that I had to come back to the UK to look after aged parents, as many people possibly have to do. And so I came back to the UK and I started off in a really good job. I moved to being head of department in a large research organization. And from there, I moved to another large research organization as head of department. But after those 2 stints, I realized actually that administration wasn't for me. When you're head of department, I was still able to do research, but a lot of my time was dedicated to administration. And so I decided to move back into being a researcher. and to focusing much more on research than administration. And I was able to move, first of all, at Rothenstedt into a strong research position, and then into the university system, starting at Newcastle and then moving to Leeds and finally to Birmingham. But you'll see my first role at the University of Leeds was as director of Africa College. And that's because during my career as I developed, I started to see that while basic research was wonderful and important, the implication of that research, the translation of that research to help the wider community was really important, and never so much was that needed as in Africa. And believe me, unless we can make Africa green and Africa fertile and verdant in terms of developing crops for Africa, then we will be in a dire situation by 2050, if not before. So I started to not only be involved in basic research, but the translation of that research, particularly for Africa. You'll see I had different jobs, as you say there. I found that it was good to move to different institutes. It's enriching. It's always problematic moving. You have to set up your lab and things, but it's really enriching to move to work in different organizations, to experience relationships with different people and to involve new networks. And as you look down at the second part of this slide, you can see that also during that time, I have emeritus positions and adjunct professions and positions at other universities, particularly in China. I have very strong links with colleagues in China, and that has been immensely enriching. It has enabled me to develop my network, to develop my research, and I'd recommend it to anybody. The ability in science to collaborate globally is truly wonderful.
Please do stay online with us. Please do stay online. Yes. Thank you. You have heard the applause from the audience. That's for your wonderful. I find your journey really, really interesting. So we do have a question for you, and it's related to the impact of COVID. The question goes, how has COVID impacted the agriculture and food security scene? And what have you done to deal with such an issue? So as a plant scientist, when you look at the COVID's impact on agriculture, what do you see and what are you planning to work on?
Yeah, okay. COVID impacted science very, very dramatically. The restriction, at least in Europe and America, on scientists going into the lab was very, very important. It stopped a lot of research. A lot of the scientists, visiting workers that I had in my lab, for example, from China, had to go home right at the start of the pandemic. There was really a severe restriction on any of the science that we could do. And part of that was actually involved losing material. Because we weren't able to be in the lab for very long, we did lose plant lines. We lost isolates in the lab simply because we couldn't continue to generate new material that would keep it going. So the science was severely restricted. And I do believe we're only now just getting back to being able to work in terms of productivity. We're now getting back to normal. The food sector, I don't believe, was particularly negatively impacted by the COVID pandemic itself.
Thank you very much, Professor.
Yeah, thank you.
Thank you so much. If we could have you to stay online, because we're about to have our panel discussion session where we would like to invite you back on again. So please remain online with us. Once again, ladies and gentlemen, a big hand to Professor Foyer for your sharing with us. And up next, we'd like to proceed to our panel discussion session. Once again, I encourage our physical as well as online audience to submit any questions if you may have for our panelists. And I would like to introduce you first off to our moderator of the session. We have the honor of having with us Professor Shoukan Chang, Chair Professor of Molecular Medicine in Department of Biomedical Sciences and Department of Material Science and Engineering from the City University of Hong Kong, who is not only our moderator of the day, but she's also a member of the HKLF Scientific Review Committee for the selection of young scientist participants in the inaugural Hong Kong Laureate Forum. Thank you very much, Professor, for doing us the honor. And we have on stage once again Professor Ng, and joined online by Professor Foyer. So, Professor, the stage is all yours.
Right. So thank you, everybody, and thank you, Professor Foyer, for staying online, and also, thank you, Professor Ng, for being here. So being, this panel discussion, and we are running short of time, so probably, I will actually pick out of all the discussions something that is closer and would like to, start it, with that. Now, we actually have schoolmasters and institutions and also students here together with, our panel speakers. Maybe I'll start, trying to get some sense about now. We have heard, the two stories shared, and then all the other, prominent scientists that we could name. Maybe we should, start a discussion on how to groom the female young researchers and make them become the future Wonder Women in science. I think that we have the students here, but maybe I would like to invite first of all Professor Foyer, because you were going to share with us a lot of the tips. But now I just want to direct you to say what can be done to groom our female young students, the young researchers, to become the future women in science.
Thank you so much. The first thing I would say is that it's important to do something that you love. It's absolutely true that if you have a job that you love, you never work a day in your life. So find a topic that really interests you, because that will see you through. And then develop a good network. So not just in your university, but have colleagues that you can talk to and discuss, and also find a good mentor. Good mentorship is really important. A more senior woman scientist who will help you to discuss issues is really, really important. Those are my basic tips.
Right. Then Professor Ng, please.
Well, I absolutely agree with Professor Foyer. I mean, I think at least, I must say, in Hong Kong now, this is really the golden time, actually. Maybe 20 or 30 years ago, I think journey may be sort of harder, and we heard the first speaker, Professor Idnes, told us about that. I think in Hong Kong now, there's a huge, change about the resources and change in policy in trying to basically groom sort of scientists earlier on, basically. And I think there are now, resources for that and infrastructure. So I believe that as people who love what they do and have passion, it's important to create opportunities for yourself as well, and seek out from those, from maybe different types of mentors along the way. And I always think that when you meet different people, diversity is really an eye-opening experience. And for young people, you may not know initially what type of science you like, so don't close the doors. I say keep an open mind for everything. Sometimes the scientific discovery or your journey also depends on who you meet, and the doors may be open. So just be ready when the opportunity comes, and so that you can actually sort of seize that.
Right. So maybe I can be a bit more direct. We have, school principals here amongst us. And is there anything that you think we can do to groom the young female, students to be, like aspiring the young researchers and then the Wonder Woman, in the future? Would anyone like to answer?
Thank you. I suppose in schools, yes, we all said, we need to produce school results, but we shouldn't really always want to put that as the top priority. Instead, allow students the space and the time to explore into things that interest them. After all, the syllabus, the so-called syllabus, is very restrictive, but we are seeing young people getting a lot more interested in things outside the classroom, and we shouldn't stop them. And instead, school could these days bring on board external help, because after all, the staff, the teachers at school, they have the duties to deliver, but we can capitalize on people outside school who are interested to share their knowledge, their expertise with our students. And like, for example, for our school, we are just in a few universities are very near us, in the proximity. So we allow our students to go to them after school, and sometimes and universities are very open-minded these days. Now they allow and welcome young students going to them, start doing something that interests them and which perhaps they can just continue after they finished high school. Thank you.
Thank you. So I think that, Professor Ng has shown that in her lab, she has the opportunities for interns. But since the, school representative here, other than the universities and the professors, what about the institutions, the non-teaching part of the universities? Is there anything that you think will help them, or maybe any volunteered of ideas? And anybody from the institutions want to add on that?
I find that everyone is pointing at me. So, this is why I am going to share some of my, observation. I quite agree that nowadays I think trickling students' curiosity is more important than simply following curriculum. Curriculums are quite restrictive, as we all notice, but somehow they also serve certain purposes. This is why we are still using them. Life is not perfect, but we still need to move on. So, but while we are working with the curriculum, sometimes I think the more important thing is to always tell students or tell ourselves why we want to do this. I think interests, curiosity are all very important. I think many research are curiosity driven. This is perhaps the foundation of everything. So after all these curiosity-driven research go to certain stage, we're going to something called applied research that can go into application, and then at the end, some of them might go into tech transfer or entrepreneurship, which is also very important in driving the economy of society and keep things move on, so that we are able to build an ecosystem, an infrastructure that can sustain curiosity. Otherwise, if everyone is only doing, dreaming, their life cannot move on. So I think we need to have a more balanced ecosystem that the whole society can move on. At the same time, we allow certain groups of people to enjoy their fantasy, and then we keep on, dreaming, and brings new stuff to society in order to bring, betterment for the mankind. This is why universities are more open nowadays, as you have noticed. I think there are several reasons. I think apart from doing education. I think another equally important reason, which is a practical one, is that all universities nowadays would like to bring in the best students to our campus. This is a very practical reason why we are doing that. But this is a good, motivation at the end. We are all achieving something that we want to see. So I'm also doing a lot of mentorship myself to different secondary school students. Many of them are female students, actually. Nowadays, I noticed that many female students are interested in studying science, engineering. My own background is in engineering, but basically, I think they are very similar in nature. Just one is more, basic. The other one is more applied. Somehow, I don't see any conflict between each other. I think now many basic sciences are also moving into, a very engineering-oriented disciplines, and engineering disciplines are also moving into very academic research. So we welcome students to go to university, and I sometimes learn from these young students. I think if the old guys are able to learn from the young people, I think that will be a very healthy system. So I want to see this type of system go on. Thank you.
Thank you. Right. So since I have the privilege of being chairing this panel, maybe I just want to use the last few minutes to see about people who have international experience, to see whether they have seen Hong Kong, or they have known to other parts of the world like South Africa. What can be done? I apologize about not talking to you earlier, but we have a consulate representative. Is there anything that you can share with us from the French perspective and in Hong Kong? If she can have the microphone as well.
Okay, thank you. I think one thing which is really important as part of our French perspective in Hong Kong is to try to build also a kind of mentorship between all the scientists and also the young ladies. That's why we're also having a cycle of conferences a bit similar to this one. It's just to try to inspire young women and young girls to follow this career, because I feel like Hong Kong and France are a bit similar on that aspect. That nowadays more and more women are thinking of this career, and the fact that there is not enough representativity can prevent some young girls to follow their dreams, which is really unfortunate, because our goal is to have many talents, especially in the science fields, and with all the issues that we are facing right now, such as sustainable development and all the climate crisis going on, and we need more and more talents to tackle these issues. So it's really important that young ladies and women will be feeling confident to pursue this. And that's our goal mainly in Hong Kong, is just to help any woman to feel confident in this field. And I think mentorship is the key, because once you see a woman dealing with the same issues that you could face in the future, then you're more willing to do it. You have especially some fields, for example, or issues that you don't think about it. But as a young researcher, maybe you're going to start your own family. And what do you do when you have children and you pursue your research? And when you see more and more women having a family and also pursuing research, then it helps you to think that you can do the same. And I think that's really important, to emphasize representativity as you are doing it right now.
Okay, thank you. Yeah. So we have about 2 minutes left, and actually I want to, ask Professor Foyer this particular question, because I look at, your different experience with, France, and you are, have links with China, Africa, and I from your, what you have shown, I don't know whether you have spent time in Hong Kong, but I think that, you have the privilege to be, having firsthand experience with different cultures that may or may not treat, young girls, young females the same. And now that, we have the French perspective, which talked about a mentor and a lot of activities. From your angle, if you have just 1 minute left, what will you tell the schools who are represented here, and also institutions, who are represented here? What can be done, that is culturally sensitive and also culturally neutral to promote more females to move forward to become the future Wonder Women in science and engineering?
It's not always easy in some cultures for women to progress, that is for sure. And that still exists in the world today. I do believe that it is important to inspire education. No education is ever wasted. So if it is possible to inspire young women to be interested in science, then they will continue. The harder part, I think, comes when they are married and have children. Persevering through that is the hardest bit, and that's where cultural restraints often come in the hardest, so that women find it hard to continue after having children in their careers. But I do believe that if people are passionate about science, they can find a way. And so always, always, always remember that it is inspiration that drives you forward. And the learning that you have is really, really important. I can't say any more, even if that learning is only passed to children.
Okay, so with that wonderful comments, and I thank all the people who I have just, directed the questions to them. But I think that we have, listened to really, wise wisdoms and different perspectives. Thank you, everybody, for, participating in this panel discussion. Thank you.
And a big thank you to our panelists. Thank you so much. Professor Ng, if you would please be seated. Professor Chang, if you would please remain. And once again, we would like to thank Professor Foyer for being with us today on live. Do keep well, and we hope to greet you at our next event. Goodbye and have a great day, Professor Foyer. Thank you. Well, ladies and gentlemen, after the very invigorating discussion on the panel, we would now like to once again invite Professor Chang to come forward to the stage for your presentation, please. Thank you.
Right. So I'm very well aware of time and that we are running late. But I just want to share with you my story. We have, listened to different versions of how they come along. And that for those of you who might, want to have a take-home message from this talk is that I just want to say that you are able. To the, female and male students here, we are not trying to, promote just the females. I think that what I'm trying to say is that for the young people in this room, my, take-home message for you is to know that you are able. You should have aspiration. And then, with a bit of luck, or probably lots of luck, and with tons of efforts, you will be able to achieve what you set out to do. So I just want to introduce myself. I'm Sok-Han Chen, and I'm a biologist. I work at City University. So this is actually a very personal journey that I want to share with you, because I think that we talk about, what everybody can do. I can tell you that I'm a local product. I came to Hong Kong 10 months old as an illegal immigrant, and here I am, I'm able to contribute to the place that gave me a shelter, educated me, and gave me a platform to share my story. So there are a few things here that I just want to list it out so that, when I go through the stories, even though it might not be obvious, that at least you know what I was trying to get you to do. So you look at the pictures of me growing up, looking different. And the point about it is that family and friends. So for me, I try not to show, the pictures of my family and friends because it is the private part of me. But just to show you how I grew up shows that, I didn't grow up on my own. I have lots of support. And that is your network, which, some of the speakers has also talked about. And then I will go through slides to showing you about mentors, colleagues, and my team members who supported me. And with my, one example for research, I want to show you is that what I started to do, ended up with a very different, outcome. And that is what I meant by luck. Luck is not exactly, getting what you want. And sometimes it's better than what you had planned to get. And for, the point 3, I think this is a particular tips I want to share with all of you. So to stand up and talk about my story, it actually, made me very nervous. So this afternoon, I gave 2 interviews, and I had hiccups. I made tons of mistakes. I was so scared about, talking in public. But it doesn't mean that, I'm not required to do, or, in a sense that I enjoyed it, because I think that, doing something that is scary, speaking in front of people, having cameras, recording it, is like watching horror movies, okay? You get the thrill. You are really scared to death. But, at the end of the day, it is a good adrenaline rush that you enjoy. And that the last, 3 points is that some of you have already said. It is about aiming high, and that is essential and important and critical. Just because where you are now doesn't mean that we expect you to go to the moon. The handling of the expectations of yourself and managing your parents' expectations is difficult. But it doesn't mean that you should not aim high, okay? Aiming, to the moon might be a bit, difficult. But if we aim, the IFC tower or the ICC tower, at least that is something that you can look at rather than the moon, and you eventually get there. And once you pass the ICC, you will get to the moon, and then Mars, and then beyond. So, doing it one step at a time. And that, so this is somehow, the summary. And this is my way of teaching. I started out with what, I want the students to know in case I didn't explain it well. And most of the time, after this, they will start looking at their mobile phones. Now, this is, a picture of my academic mentors. So the first one of me wearing the Chinese, uniform is actually with my first boss, Professor David Higgins, and his wife. And so, the lesson I learned from him at the age of 22 is to find out what is, what is it all about doing biomedical research. So it was my first job. I just got a research assistant job in the University of Hong Kong, Department of Pathology. I got it because I just love doing laboratory science. And unlike my peers, I didn't think about doing higher degrees. I thought that that is for the rich people. For people who is, coming from a humble background in the public housing estates, all we need is to get a job because my mother needs the money. And so I got a job, and then he said that this is, maybe a research assistant's job, but you have to know why we are doing biomedical research. So he said that every Wednesday morning we will have the kidney, patients who will come and do the HLA tissue typing, human leukocyte antigen typing, because they will be waiting for donors' kidneys. And, and so, just look at them and see, and then you'll understand why we are doing research. So the first Wednesday morning of that week, I sat, in the tissue typing reception room, and then I saw somebody walk through the door, and I was totally shocked because of the complexion. It is really like earth color. So in Cantonese, we talk about 面如土色. So, I only read about it. But when I saw the kidney patient walking along who probably had been on dialysis for a long time and waiting for a kidney transplant, I was totally shocked. Is that first, someone can be this ill and still want to live. And we can actually have, a solution if we can find a donor that matches it. So that is the whole point about, scientific research for me from my first mentor. And then the second mentor, you can see, the professor in the middle. He's Professor Danny Mitchison with his second wife. So he came from a very privileged family. His grandfather on the mother's side was the Prime Minister of the United Kingdom between and after the First World War because they were too pro-Germany. And so, for him, the lesson he told me is that, Han, no matter how senior you are or how high you are in the ladder, in the career ladder, there will be somebody who's on top of you and appraise you, criticize you, tell you that you're not good. So just, don't think that if you just climb higher and higher and higher, you will escape that. No, that is a fact of life. So better learn how to be criticized, appraised, and take it, not personally. Because when it comes to work performance, it's not about how nice your boss is to you, it's about how well you perform. And then, and then we have Professor Ted Mack, he's my postdoc supervisor. He's now got a Hong Kong lab. And so for him, the take-home message is that, Han, time to milk the cow. So, for him is that I have done quite a lot of experiments. I was not confident enough to write it up as a manuscript to submit it, because I felt that if I spend another 3 months, I'll get it more perfect. But then he said that just go and milk the cow, That is his way of saying that start working on it, get it out. It may not be the perfect thing, but really get it down and write it. It is really about the confidence, which I think that a lot of you, will think that if I am giving more time, my paper, I will study better, but actually just do it. But why I'm showing this picture, I apologize for not having the spouses of Ted Mack, because I didn't have picture of his first wife, he was lost. But then why I'm putting the pictures of the spouses? First of all is that the spouses of your academic mentors, they are usually very accomplished themselves. And also they are very supportive because they know how to spend time with somebody who's high achieving, critical, and demanding. And they will actually give you advice is that don't take it too badly, he does that to everybody. But also there is, the point about when you interact as a female with a male, superior, it's always very good to think about is that outside of the work itself, it's good to have, an interaction with the wives as well. Then everybody knows that it is, nothing funny. It is really a good social interaction, academic mentorship, and also that is a good relationship. And then, a lot of people, they're very afraid of their bosses. But I just want to share with you, it may not be, the same situation, but for the students among you is that, the teachers, the school principals, or some very famous professors, they are so good. I'm afraid to talk to them because they will know that I'm not that good. So my advice is that don't mind that. You may not be that good, or they may be really good, but they are humans, and they choose this profession because they are nurturing, they mentor, they might be extremely busy. Do remember that. But they are willing to nurture people. So this, picture of me and Professor Donson with 3, university presidents is that we wanted to organize a conference. So we asked the 3 of them to be the patrons, and they all say yes within an hour. That means that even though they are very, very busy, they still want to have, this time to nurture junior people. And whether it is, from a student to your principal or from junior scientists to your own president, go and ask them directly. And then, I have other pictures, but that is the same story. Do not be afraid to go to very, senior people to ask for help. And also do not be afraid to tell them your plan. It might not be significant, in their eyes, but that is for them to judge. But you will be significant to them because you go and ask them. That means that you respect, their authority, you respect their network, you actually want to use them. And they love that, okay? And then I have, different lab members. I couldn't take out all the pictures, but I just want to show you is that I work with lab members from different cultural background, and then and they all have something, to contribute to the lab. Some ended up, after a PhD and just went and worked for China Mobile as an executive. It doesn't matter. The PhD that any of the students did with me means that it is, a training, and that I send, them out to different places. So that is a picture of them in Korea. So, I will just finish it very fast now because I talk too much. So I just want to say that research is an interdisciplinary story, and that you really have to work with people of different backgrounds. Learn how to interact with them, speak their language, get them to interested in your project, and work as a team. And this is, my graph of relations that I, just mark out all the researchers that are, connected with me, and you can see the lines. So the older you grow, the more lines you have, but it is a joy in life to have more interactions. And this is, the last bit. So I spent 10 years to make a transgenic fish to measure estrogenic pollution in marine, So an unexpected turn is that this young team, they licensed the technology for testing marine pollution into, food safety and and personal product testing. And so they won a big award. They are now, a very, noticeable startup company. And so, and I think that this is, what I want to end here is that we are all able, and you are all able. Just make sure that, you aspire high, aim high, and then with lots of luck and tons of efforts, you'll be able to get there. Thank you for your attention.
Thank you so much, Professor Chang. If you could please remain on stage. Please do remain on stage. There is a short Q&A session, and let's see what the audience have for you. All right, it's well known that you have won a lot of international innovation awards. How do you keep having new ideas, and what's your take about the relationship between pure science research and innovative discovery?
Maybe I'll use the mic here. So first of all is that I think a lot of people said, scientists, we are curious. So I have tons more questions, but I just don't have the resources to develop experiments and work on all of them. But the awards are just, like Professor Ng say, there's a lot of sponsorship. So either you nominate yourself or you ask people to nominate you, just try it. It doesn't matter if you don't get nominated nor even don't get the award, but it is a good experience. So the essence is not about the awards, it's about, having lots of questions and stay curious.
Right, and I think also in your sharing, a lot of learning is in your attitude, how you pick learning from your mentors, etc. And even when you approach an innovation award, that's what you teach us. So thank you so much. If you could give us a roundup of today's event in a few sentences, that would be lovely. Thank you.
Right, so being the moderator and the last speaker, I have, the privilege of holding the platform and have the last words. But first of all, I would like to, thank everybody for showing up. The students here, the students online, and the different hosts, and also, the institutions, schools. It shows that in Hong Kong, we do care about our young people. We do care about nurturing the next generation of wonder women or wonder men that will go into science, because we are going into the era where whether you are a businessman or whether you make drawings, it will have to be dealing with STEM. So my last word is to thank everybody for your efforts, including the council. I think that it is a societal reckoning that the youngs are here and we are nurturing them. And I hope that the young people, could feel that we put in a lot of efforts to tell you that you are good, you are worth it, and we are investing hugely into you, And so just be yourself and do what you want to do, and we will be here, including your principals and professors and from the society. And then on that, I'll just close this, panel discussion. Thank you.
Thank you so much, Professor Zhang. Thank you. Well, ladies and gentlemen, we have now approached the end of the official seminar part. I would like to invite us all to put our hands together for our great lineup of speakers and panelists who are joining us in person and online. Thank you, everyone. And on behalf of the HKLF, I would like to thank you for joining us. Just a reminder that a recording of today's event will be made available on our website quite soon. So if you'd like to watch a playback, you could go online once again. And we hope to see you again at our coming event soon. Thank you, everyone, for joining us online. Have a great day. Thank you.